Welcome back to the hyperbolic coding chamber. We are back once again. Another day, another dollop of suffering for everyone who has signed up to this godforsaken website. So it is unfortunate, but it is what it is. So we're back once again. I think we've been doing a lot of short sessions recently, so I'm thinking I might kick the sessions back up. It could be useful, I'm thinking now. So yeah, there's a lot of algorithmic problems that I don't know. I feel like it's like algorithmic fitness basic. It's like a algorithmic fitness, I feel like. So it doesn't I don't know if it translates like to someone being like really good at programming, but I think there is something to like you're breaking out part of the problem in LeetCode, you're breaking it apart in your head, you're thinking about different ways to solve it. At the end of the day though, I think it is a different skill set to problem solving like you would on the job. But nonetheless, this stuff does make it easier to understand other stuff. So like there was a problem we had to do with like bits or something like that, and yeah, there was just a problem. I think it's called It's called count number of 1 bits, but it's really just called the Hamming weight. And I didn't realize how many different ways a problem like that could be used, but it's actually really common, which is really interesting. And yeah, understanding that one problem and having to reuse it in so many other places has pretty much made me think has kind of forced me to understand stuff I didn't want to feel like understanding, like bits and stuff like that. So our bit knowledge is definitely better than it was when we started. So 144 days into it, a lot to think about. But now I'm thinking if we poured more time into it, we could go faster. So that's always true. So like we said, sometimes you got to walk to run. So I think we may start running again and pouring more time into it. So that could be cool. Progress could be even faster. I would really just so that's kind of where we're at. But we have some questions as well. Oh yeah, so yeah, yesterday I did a silent session. Yeah, I had a family member in the hospital, but things are looking up. So appreciate the comments. Hope family's well. Hope you are well, brother. Hope family is well. Keep pushing. Will do. And then we have a comment from Humble Coder, which is a cool name. On day 140, oversimplification is also bad. I just did this problem the other day, using prefix sums. Pretty sure this problem was the pivot index problem. And prefix sums, I'm not exactly certain what prefix sums is, but generally the intuition here seems like it could be very true. So I feel like this is probably true. And we have Yo W, got a cool surprise for you if you decide to do game dev. Yeah, I mean I've been doing, I wouldn't say I have been doing, but I dipped into game dev a long time ago. Dropped a couple of multiplayer games. There was another one, so a couple of mobile app games too, but hoping things might be different sometime. I think after my first couple of games or mobile games, I was kind of disillusioned from the way the industry works with mobile games, because I know people have probably seen those ads where it's like only 1% of people can figure it out, and it's just like a square triangle, and it's like the person just has to put this triangle into the triangle hole, but they're trying to put it into the circle hole. It's just crazy. But the advertising works, so I don't think the advertising game is definitely a random walk into success. So I feel like they wouldn't have been using that ad format for so many years if it wasn't actually successful. So it seems like it works, but unfortunately I just didn't want to make more games that are racing to the bottom of the brainstem along with advertisements. But I'd be interested. It sounds like Botea may be working on some games. That's pretty cool. Loving I think the same comment. Yeah, feel strong. Loving the content you have and go with LeetCode grinding like a Fang job. Much love. This would be dope. Fang would be cool, but at the same time, I'm kind of using LeetCode as a vehicle to train focus. So the focus I get, like sitting down and having to do it, helps me focus in other aspects of my life, which is really useful. Also, this section next to me is really dirty. I didn't or unorganized, but yeah, that would be the goal. The real goal, I would just like to finish the challenge. I just wanted to be able to finish all LeetCode problems. I know other people have already done it, but I just want I just want for me to have done it. And then, yeah, I think from there, I'll just keep doing it. And then maybe we'll top the charts every week. I'm not really certain. I think it's just, I really like to finish all the problems. I'm not exactly certain why. But if there's anything I've learned over the time, I think sometimes trying to figuring it, at least sometimes when I tried to figure out the why, I feel like I end up just kind of spinning my wheels forever. So sometimes I feel like figuring out the why is a trap, because then I end up thinking too much about what I'm doing. But and then once I do that, I don't really make any progress. So I just try and focus on the challenge itself. But it would be cool. It would be cool. It would be cool. So yeah, it would be cool to finish all the problems, and I'm hoping it would also keep me algorithmically fit too, because the job markets can be pretty crazy. So yeah, it'd be cool. It would be pretty cool. I also think there's a lot of low level stuff where regular programming is kind of not really useful, like in terms of like the problem solving based version. But knowing about some of this stuff can be really helpful. For example, if you're making your own game engine, I don't think you need to know like every problem on LeetCode, but there's some concepts that are useful. Like you'd have like a node graph, or maybe you're using a form of vertex or normals mapping that needs some algorithm. Might help you, might be easier to understand those things. For example, there's one networking algorithm where you're synchronizing locations based on data received from the server. And I remember looking at it a year ago when I was doing LeetCode more frequently, and it was easier to understand the problem. There it goes. It was easier to understand the algorithm because I was viewing it as a problem. And I just said that earlier, but yeah, I was like, oh, this is just like a LeetCode problem. I just had to understand what they were doing, and I was like, oh, I get it. Whereas like before, when I'd run into a piece of code that I hadn't written myself, it was like a big issue. So maybe another thing that it helps with is reading the solution and having to read other people's code. But I'm sure there are other ways around this stuff. But yeah, just some interesting things. But today we're going to do an hour and a half. We have the LC contest that we're going to try. This one looks like it was pretty difficult, but I don't really know. I just realized that a lot of the actually no, we're not going to do the LC contest this week. It looks like a lot of the problems that we've been having to do this week, last few contests, have been like very they've been like very math flavored, and it just hasn't been very interesting. So I think we're going to keep moving with the easies. I've been keeping an eye on the question count to know whether or not LeetCode is adding 45 questions a day. Doesn't seem to be the case. Maybe it's more of a weekly thing, but yeah, we'll see there. We'll see when we get there. And yeah, we'll see when we get there, and let's just jump into it. So we have some problems to be done. Also, thanks for all the family comments and just general comments in general. Always much, much, much love. But we do have a problem for which we do not love, and that is 1009. So that's what we're going to jump into, and we have quite a few problems to do, so I'm just going to jump into it. So here we have complement of base 10 integer. The complement of an integer is the integer you get when you flip all the zeros to ones and all the ones to zeros in its binary representation. Okay? And I guess 2's complement is when you flip all the bits and add 1. For example, integer 5 is 101. In binary, its complement is 010, which is the integer 2. Given an integer n, return its complement. I see. So it looks like we're just flipping all the bits. Looks like we're just flipping all the bits. Is there anything magical to that? I think we can just we had 101. We want to pretty much flip all the bits. So we could just mask it with 1. If it's 1, we'll add 1. If it's not, then we'll... The problem with that, I think we've done in the past, is that the number comes out in reverse. which is really annoying. I think there's a method for which we usually implement bits that is just kind of ghetto. But I think we can flip it using OR. Actually, OR would just add the thing itself. So I think we could do that. If we're assuming we have 32-bit, if we're assuming we have 64-bit integers, we can just, for each bit, we'll calculate what the actual bit value should be, which should be 2 to the, it's either 1 or 0 based on the place value, times 2 to the starting at 0, would be going up. So from there, we'd get a value like 1, 2, 4, 8, 16, 32, 64, and so on. And then from there, we can just mask the number in the standing number. If we mask the number and it's true, then what should go there should be nothing. But if we mask the number and if we mask the number, we'll leave nothing there for 0 because we're flipping the bits. But if we mask the number and it's 0, then we'll mask it with the place with the calculated we actually don't need the place value because we just want the actual like locations, spots of the numbers. Then we can just mask it with that value. I mean, or the flipped version with that value, and we should be able to flip the bits, I think. So yeah, I think we should be able to run with that. So basically we're going to iterate, we're just going to assume 64-bit. So then we'll start at I equals, we're going to have a power power. Yeah, I think the power can actually just be the iteration because power is going to start at 0 and our place is always, we're in binary, so it's always going to be 2 to the power to get the place value. So do power is less than 63 because it's actually exclusive of the last value. Do power plus plus, and then we'll have n, we'll have flipped equals 0. We can return flipped down here. We have a semicolon there, and then from here we just like to mask the values if it's actually true. So you could say if and, or I guess we'll say let value equal if and 2 to the power equals 1, then the value here flipped should be 0. But if it doesn't, it should be 1. And then pretty much if value is 1, right? If it's 1, it's when we're actually going to be writing into the flipped value. So we do flipped equal flipped, or, and I think this bitwise or is what I'm looking for, 2 to the power. So if you run this in our heads, we'd have the Bitwise component, right? Power going from 0 to 63. And let's say we had 5. 5 is represented as, we take the first 3 bits, but we'd have 1, 2, 4. We'd have 1, 0, 1, right? And then we'd say 2 to the power, which is 1, if and 1, which it is, value would be 1, which means you'd like that to be 0, which means you wouldn't OR it. Then we'd say power would be 1, that'd be 2 to the 1, which is basically just 2. And then we check if that value exists. In 5 represented as binary, it doesn't exist because there's a 0 there. So right, and that's what value, if it doesn't exist, right, value's a little bit confusing. Call it should flip, right? If it should flip, this one will do 0, and it will mask it with 2 to the power, which is 2. Should we flip it, n and 2, n and 2, 0 and 2, which would actually give you 0 if we masked it. Now, if it's a 0, that's when we'd actually like to flip it. This is if n and 2. So if we mask it and 2 exists in the spot, then we'd like to flip it. I wrote this as a ternary. It's kind of confusing, but I think I should swap these. N and 2 to the n and 2 to the power. I think if I write some parentheses here, it should be easy to think about. 2 to the power. So that means we're looking at the 0. If we do 0 and 2, we'd like this to become a 1. Yeah, I think I confused myself. I could have just said should flip is if n and 2 equals 0. I think I confused myself. If n and 2 equals 0, then we'd like to flip, right? And we'd flip it by saying flipped. We'd OR it with just 2 to the power to set that bit to 1. The other bits would stay. Or maybe not. It seems like they'd like us to stop. I think another thing they're not really saying is that technically, if we were assuming 64-bit integers and you were to swap this, the number should be much larger. So I think the other thing is we have to get the furthest along bit. That would be the power max. So you could let power max equal to 64. Also, this should just be 64. Actually, let me try with 64. Yeah, we're still wrong. So the power max will start at 64, and then we can actually just search through the bits. we'll just do temp equals n, and we'll have another thing. Pretty much we're just going to figure out the power max. And to do that, we can just mask the bits. So we'll just say if power max will actually start at 0. We'll say if we mask temp and 1 and it's true, then we'll set power max equal to I, and then we'll do temp, we'll bit shift it right once. Should give us the highest place, and then we can just print. Our output std out was 2, so 4 5 is our power max 2 0 1 2. I think that is true because the place where 2 actually exists, at 2 is where we actually have 1 set, then the next one we have 0, the next one we have 1. Let me check for 7. 7 would be also 2. Yeah. 10 would be 1 2 4 8. Should be 4. Oh, I guess it's 3. Right, because it's down 1. The power, because 2 to the 3 gives you 8, right? And that's the one that's set to 1. I think if we change 64 to power max, but we actually want to include power max. Oh, it actually does work. So it looks like, okay, so that's good. Yeah, I didn't anticipate that they wanted us to stop there. I feel like our version's still ghetto though. It seems to work though, but I feel like it's a little ghetto. I'd say it's constant time since we're guaranteed to do at max 64 operations and we're not really using any extra space. That's going to scale with input size. I can't see a way of this where you wouldn't have to figure out the highest. You wouldn't have to figure out the most significant bit. Maybe there's a way to figure out the most significant bit faster. Actually, there is. We don't have to do bit stuff. Can we just figure out the largest? We could just figure out the largest number that goes into the largest number that's out of all the places, right? It goes from 2 to the 0 to 2 to the 64. What's the largest number that fits into or is equal to n? And you can get the most significant bit that way. We wanted the place of it, but you could also do that as well. What we did was just look through all the bits going from right to left and just keep the one with the high, just kept the most recent one that was set to 1. Oh, wait, XOR. XOR of 0 and a bit results in that bit. Oh, so I think we just learned a trick. So it's exclusive OR, so it's one or the other, but not both. So the XOR of 1, XOR of 0 and a bit results in that bit. Right, because pre-0 is basically a no-op. XOR of 1 and a bit flips that bit. Because if it's 0 and 1, exclusive OR is either 1 or the other, so we turn a 0 into 1. But if it was 1 and 1, it's XOR, so we get 0. So XOR of 1 and a bit. I actually don't know what the XOR operator looks like. Oh, it's just caret. Okay, so now that we know that, let's see if we can rewrite this problem real quick to use XOR. We still need to know the most significant bit, except now we don't have to set it to 1 by using OR. We can just use XOR. Actually, how would you even... I think you'd still use OR here, except the part where I'm doing 2 to the power, you can just do... We don't have to worry about should flipped, I think, anymore. We could just say flipped is going to be equal to flipped, or, and this is how we're going to actually put the value in. Oh no, I guess you'd just say if flipped XOR 1. Well, no. Flips that bit. If it flips the bit, you still need to iterate through it. You still need to iterate through it. Or maybe there's something I'm missing here. You still need to iterate through it to flip the bits. I'm not seeing how this is better than what I have now. Oh, yeah, so we did bit by bit. But you could do it faster if you just can. I actually wouldn't really be faster because to construct the 1-bit mask, you just be batching the operations at once. Maybe it would be slightly faster. Initiate 1-bit variable which will be used to flip bits one by one. So n XOR the current bit. N XOR the current bit is how you could flip the current bit and retain the number. If n equals 0, return 1. We flip the current bit because the XOR of the current bit. Why are we left shifting bit? I don't get it. Why do they have to shift bit here if bit is going to be equal to 1? If bit is going to be equal to 1, shouldn't it just stay that way? I'm not understanding. Let me try it my way. If we keep that function, why do you have to shift this left? Oh my god, I just got it. We need to be the number n, right? We need to be XORing it with the bit for its place. I don't even know how you would say it, with the bit for its location, for its place. And this is what they're saying. You take the 1 here and we shift it 1 down, right? So now we can mask it here. Then we shift down again so we can mask it. So I see. And then mask XORing it with that also means that once you know what? I think we've learned enough from this problem. Let us move on. So we have design hash map. Design a hash map without using any built-in hash table libraries. Design a hash map without using any built-in hash table libraries. Design a hash map without using any built-in hash table libraries. Implement the myHashMap class. MyHashMap initializes the object with an empty map. MyHashMap initializes the object with an empty map. Okay. So constructor void put, we're going to put for a key, a value inserts a key value pair into the hash map. If the key already exists in the map, update the corresponding value. And get returns the value to which the specified key is mapped, or -1 if the map contains no mapping for the key. Void remove key removes the key and its corresponding value if the map contains the mapping for the key. I see. I think there's a couple of different ways to do this. One way, ideal hash map would have, for retrieval, I think the ideal hash map has retrieval, constant time, amortized. With insertion also being constant time amortized. I think when you insert, you'd like it to be relatively instant. And when you retrieve, you'd like it to be relatively instant. Amortized meaning that in some cases it could take linear time, but over time it should average out to constant time, I think. Couple of ways to do this. I think one way is the bucket method, the bouquet method, but it's hard to know the bucket size. I think the bucket method is pretty much, since our keys can be numbers or anything that can be, any key that can be converted to a number, we could have a set of buckets. And the way we would get relatively constant amortized time is that these buckets would be stored in maybe it's better if people can also see the problem. If this bucket was stored, these buckets are stored in an array, right? And the way you kind of get constant time is that you pretty much get to a bucket in instant time because it's an array, right? And the key would be the index, right? So we need a way of turning some key, right, into a valid index range. And we need a way to pretty much split them all that way as well. So for example, we could imagine if we had 4 total buckets, right? If we had the numbers 1, 11, 16, and actually 19, and 20. So these might all end up in the same bucket, I think. But the goal would be, these are the keys, right? These are potential keys. So the buckets that these would actually be assigned to, right? To do that, we'd do 1 mod bucket length, which would be 4. And we'd get 1. So this would be mapped to bucket 1. And then we do 11 mod 4. This would be mapped to bucket 3. We do 19 mod 3. This would be mapped to bucket 1. And then 20 mod 4 would be mapped to bucket 0. And then I think if we had a number like 8, no, we need something with mod, something like 11 mod 4 0, 1, 2. We need something that gives us, so something like 10 mod 4 would give us, yeah. So instead of 19, we'll do 10. This would give us a bucket of 2. So 0, 1, 2, 3, they all end up in a bucket. It's pretty much every fourth number, every fourth key will end up in one of these buckets. Issue is we won't really know the range of our keys, which is why we're saying that the time would be constant time amortized, I think. Because in the worst case, this just gets us to a bucket for which we then do a linear search for the key. And then to map it to the value, right, inside the bucket. So it's really a three-dimensional array. You have the overarching array, gets you into a key, right? And then you have an array of arrays for which you can search. And for example, we'd have 1, 1 here, right, for key 1, mapping to, let's just say the value they wanted to put in here was 9,000. Then we'll put that value. We'll put that value we'll put that value into the array. And the other thing we'd like to probably know, we can't use any built-in hash map, so it gets kind of nutty because usually you use another hash map for the keys, but that would be pretty nutty. So actually, we don't actually have to worry about. Actually, we'll know if the key exists pretty much if we try to find it and we can't. So we could pretty much implement another function called find. Find will help us with get and remove as well as put, because if we can't find it, yo, there's something in my eye. What is going on? I'll be right back. Oh, there's something in my eye, but we just have to ignore it. But I think I finally got it. So I think now we can finally focus up. So I'm thinking of using modulus as a method of dropping things into buckets. In that sense, we would need a data structure. But not really. We would just use an array of buckets. Just I'm following this. An array of buckets. Buckets also have arrays. Buckets have tuples. So an array of buckets, and then buckets have tuples. So an array of buckets and buckets have tuples. So from there, if we want to put a key in, we have to pretty much see if it doesn't already exist. So we'd look through for the key. What this also gives us is that a key pretty much is hard mapped to a bucket. So then what we'll do is when we have a key, we'll pretty much modulo it to get the bucket. Once we get the bucket, we'll just search through all the tuples to see if we can find the key. So when we put the key, we also did something to pretty much say, can you already find it? If you can't find it, we'll also, I think we can basically do this if we make a find function. This find function would pretty much find the bucket and it'll return the index of the bucket for which it exists, as well as the index for which bucket it goes into, right? And then the index in the bucket. We can also reuse this for put, because for put, if it doesn't already exist, right, then we'll have the bucket it's supposed to go into. We can just add it. Actually, no, we don't need to do all that, because we just need to know what bucket it goes into, then you add it to the array. So basically we just need a find function. The find function will return a tuple if it finds it. So I think from there we can implement get as well as remove. Actually, no, we don't even need a find function. You can just implement this. Basically, we'll need an array of buckets, and I think that should be it. We'll pretty much say this dot buckets is going to be an array and it's going to be, actually we can just set it up like this. Buckets is going to be an array of an array of arrays. And then we can also have a bucket size. I think you can use read only bucket size of 4, and we'll say for let I is equal to 0 I is less than bucket size I plus plus, we'll just do this dot buckets dot push an empty array. And then from here, if we want to put something into the, let's read the method again. They just want us to put key value pair. If it already exists, overwrite it. So insert a pair into the hash map. If the key already exists in the map, update the corresponding value. So to figure out what bucket it lives in, we do key mod this dot bucket size. Then we'll just say for let I equal 0, I is less than this dot buckets sub the bucket that you're actually in dot length. So for all the potential tuples that exist in there, right? We're going to say const tuple equals this dot buckets sub bucket sub I, and then here we'll have key value. We'll say if key, or we'll call this pair key and pair value. If key, right, is equal to, or no, if, the key they passed in is equal to the pair key, right, then that means we already found it. It already exists. So we want to say is this dot buckets sub bucket sub I to get the tuple sub 1 is going to be equal to value. Type number is not assignable to type never. I don't get it. This is a tuple as an array with 2 numbers in it. This is an array. So we get the bucket. Oh no, wait, we get the bucket. Let's see, bucket sub I. I think we can just ignore this whole thing. Otherwise, what we'll do is just create it. I don't know. If we get to the end, I think we can just use get actually. So we'll say, if we want to do put, we'll check if it already exists. Now you still end up with the same thing. I feel like it's always ghetto to add a return. Might be easy to do something like this, where instead of actually adding the value, we'll just say if the key already exists in the map, update the core. I think I'm trying to write the function, write the data structure and optimize it at the same time. It's just confusing. I think I should just say if we found key, then we'll say found key equals true. But I think no. We would like to stop if we found it, otherwise you end up looking through every single bucket. So then we'll say found key if actually might be easy to do something like existing index should be equal to -1. And we could say existing index would be equal to I. No, this is all the buckets. Right. Now, if existing index, then we just want to say this dot buckets sub bucket sub existing index sub 1 equals value. Otherwise, we just want to say this dot bucket sub bucket dot push tuple of the key and the value. So here we would just create it. I'm not understanding why it's such a big deal to use a tuple. Type number is not assignable to type never. Can I add an empty array? Is that unacceptable as well? Yeah, I don't understand what the big problem is with using keys and values. think we might have figured out a solution. I think the method we're using to type it just doesn't make any sense. So we want an array of tuples. Which I think seems to have fixed literally everything. So that is better. There's something in my eye again. Then we have get the key. Say const bucket is equal to key mod this dot bucket size. I think it also would have been better to use something like a linked list rather than the inner arrays here, because then when we remove elements, we don't actually get good runtime. So we could just say this dot bucket sub elements from an array, and if necessary, inserts new elements in their place. So we pretty much want to start at index I and delete one element. Bro, my eye is distracting me so bad right now. Existing index. Put 1, 1, 2, 2, then we want to get 1. 1, 1. Output limit. Oh. Not the best. I feel like my eyes bothering me so much. It's just like distracting me like a crazy amount. So every time I move my cornea, it like scratches. Maybe the ideal bucket size is something like 10. What was the last run time? 525. What if we use 100 buckets? It seems like the more buckets we use, the faster this gets. Trade-off is space, however. Okay, yeah, there's definitely a location of diminishing returns. Yeah, that location seems to be somewhere between 100 and 150. So 150 buckets. That will be the time complexity. For put, the worst case that you're looking through all the elements in a bucket, which is unknown. For all of these, the worst case that you're looking through all the elements in the bucket. The ideally, it would be that I also feel like remove is making us take a lot of time, so we could just swap out splice, which technically to remove an element in the middle of an array, you have to shift all the elements down. If we swap this for a linked list, I think it would be much faster. Every time we remove an element, it pretty much takes up to the worst. Assuming we're doing a lot of removes, this would be very slow. But for all of them, pretty much worst case that we visit all elements in a bucket. I think we could go even further and we could add a page size. But who knows? It's hard to tell what the time complexity of that is. Because we can have almost an infinite number of elements. Using a dynamic array, we can have an infinite number of elements in the array. Oh, in the bucket. Also, we didn't talk anything about collision, hash function design, and collision handling. I guess the version we went for was kind of agnostic of those. Actually, we did have both of those. Hash function design, our function, the modulus spreads into an even number of buckets across the storage space, and the collision handling is pretty much we keep searching until we find it in the array. So they did the same thing, right? Except they use a linked list, right? That's what I was saying before. The bucket could be a linked list instead. They implemented some classes here. N is the number of all possible keys. In the ideal case, the keys are evenly distributed in all buckets. As a result, on average, we could consider the size of the bucket is n over k. I see what they're saying. That's true. Worst case, we need to iterate through a bucket to find the desired value. The time complexity of each method is O of n over k. Space complexity, all the keys. Interesting. Why'd they use 2069? I see. It's good to use a prime number for collisions. So I wonder if I change this to bucket size to be 2069. Wow. Actually, no. Okay, yeah, I thought it was going to be much faster. I'm sure it would be if we use the linked list under the hood, but the splice is really eating out of our time complexity. I think we should like hard remember how to implement a linked list in a shorter amount of time. So that would be helpful. Now we have find common characters. Given a string array words, return an array. So we have a bunch of words. We want to return an array of all characters. That show up in all strings within the words. Oh, I see what they're saying. All characters that show up. You may return the answer in any order. All characters. So you have a bunch of strings. I wonder if you would just say, if you had a string of Bella and Jason, would you just return A and A? Or A by itself? We can return an array of all characters. So if a character shows up in all the words, it should be in there. Including duplicates, you may return the answer in any order. So all the letters that appear in all of them are E, L, and L. So, top of my mind, I'm thinking we can just use a shared set. We use a set because we don't actually care about the value. We just want to be able to know in constant time whether or not we've seen a character before. If that's the case, we can iterate through every character in every word, and if it's in the set, we'll keep it. If it's not in the set, we'll remove it. That way we should only end up with all the characters that exist. The keys of the set should give us what we need. And we can return the answer in any order. So we create a set. It's going to be a new set of strings. Then we'll iterate for const word of words. And then for const letter of word. The time complexity would be the O of S, where S is the sum of all characters in the string. So we'll just do if set dot has letter, then we're probably not going to do anything. Now if set doesn't have the letter, if the set doesn't have the letter, so we have B, set has a letter, we'll keep it. Wait, I'm getting a little bit confused. We have Bella, label, and roller. We iterate over Bella. We'd add B-E-L-L-A to the set. think I'm getting a little bit confused because I think you have to do a full iteration through first and then a second one. Reason being, if you add B to the set, then E to the set, then L to the set, you'd find L in this. You'd have L again to process. So you'd say, okay, is L in the set? It is in the set, so we'll keep it. But if it isn't in the set, you would remove it. But it doesn't make any sense because if it isn't in the set, you'd add it. So I think what we really just need to do is just go through it once and do set dot add letter. Then go through it again. Now we'll say if I have a set of all the letters Wait, why is this problem messing with my head? If you already add all the letters to the set, then it doesn't actually make any sense. Because when you check if the set doesn't have the letter, it would already exist. Pretty much the first word sets the precedence, basically. Mm-hmm. I think what I want to actually do is load up the set with Bella, and then if it's in the set, we'll keep it. If the letter's not in the set, for example, like if R is not in the set, B is not in the set. Once you get to ROLER, I think I'm realizing where I'm getting messed up. I'm thinking of the problem as in we want to know whether or not the letters in the words exist within the set, but it's actually the opposite because what we want to know is whether or not the keys in the set exist within the words. So instead, I think what we want is the answer set, which we're actually going to load every letter of the first word into. And we'll say answer set dot add letter. What we actually going to return is the answer set for the keys. We have another set, which is the word set, which is a new set of strings that we're going to create by iterating over the word. From here, all we need to do is say for const key we pretty much want the union of the answer set and the word set. And to get that union, yeah, we actually don't want the union. That's why I keep getting confused. We don't want to know which one. Yeah, we actually do want the union. What's shared is R is ELL. And to get the union of those, you can do it from any side. So you can say for const key of word set if answer set dot has key, or if it answer set doesn't have a key for it, then we'll do answer set dot delete key. Oh, and instead of doing for const word of words, since we're going to end up adding them back in, I think what we want to do is say const word is going to be equal to words sub I, and we can swap this whole part in here out and start I at equal 1 because we're going to skip the first one, go over words dot length, and then words plus plus. I mean, not I plus plus. Answer is still wrong. So I equals 1. If I print the answer set, oh, I think I see the issue. I didn't look at this. But yeah, we should just read the problem slower. A set would never work because you can have multiple characters. They're not asking for the unique characters remaining. So the problem here, I think we can solve this tomorrow. I think with my eye bothering me, I think I just ran out of brain sauce. So we'll come back tomorrow. I think you can solve this with the union over two maps instead of two sets. So I'm just going to toss this code out and then try tomorrow.